Paxos versus Raft, the consensus algorithm showdown. Master the core of distributed systems.
Have you ever wondered how distributed systems achieve consistency and reliability across multiple nodes, even in network failures? The answer lies in consensus algorithms. In today's video, we're diving deep into the two most popular consensus algorithms, Paxos and Raft. We'll explore how they work, their differences, and which one to choose for your system design. Stick around because understanding this topic is a game changer for developers and architects alike.
In distributed systems, consensus algorithms ensure that all nodes in a cluster agree on a single source of truth, even in the presence of failures. This is critical for maintaining consistency in databases, fault-tolerant systems, etc. The challenge? Achieving this agreement despite unreliable networks, crashes, or delays.
Let's start with Paxos, the grandfather of consensus algorithms. Developed by Leslie Lamport, Paxos is designed for fault-tolerant distributed systems. It works by breaking down the process into proposers, acceptors, and learners who communicate to agree on a value. While Paxos is highly fault-tolerant and proven, it's notoriously complex to understand and implement. Paxos is like a classic novel, brilliant but not the easiest to read.
Now let's talk about Raft, the modern alternative to Paxos. Developed to be easier to understand, Raft splits consensus into distinct phases. First, leader election, choosing one node as the leader. Second, log replication, synchronizing data across all nodes. Raft is widely adopted in tools like etstd, Console, and CockroachDB. Think of Raft as the approachable, user-friendly version of Paxos.
So, how do Paxos and Raft compare? Simplicity. Paxos is complex and challenging to implement. Raft, on the other hand, is designed for clarity and ease of use. Performance. Both algorithms are similar in performance under normal conditions. Raft may have an edge in practical implementations. Adoption Paxos is used in academic research and a few systems like Google Spanner. Raft, however, dominates the industry with implementations in Kubernetes, etc. and more. Paxos set the standard, but Raft made it practical.
Here's how these algorithms are used in the real world. Paxos powers global systems like Google Spanner, where consistency is critical. Raft forms the backbone of Kubernetes, etc. and distributed databases like CockroachDB. Both algorithms ensure fault tolerance and consistency, but the choice depends on your system's complexity and requirements.
Here are some tips for implementing consensus algorithms effectively. First, use Raft for clarity and ease of implementation in modern systems. Second, choose Paxos when academic rigor or complex fault tolerance is required. Third, monitor network partitions and node failures to ensure reliability. Finally, use consensus libraries like Raft libraries or tools like Zookeeper to simplify implementation. Consensus isn't about picking sides, it's about picking the right tool for the job.
To recap, first, consensus algorithms like Paxos and Raft ensure consistency and fault tolerance in distributed systems. Second, Paxos is highly robust but complex, while Raft is simpler and more practical. Third, both are critical for building reliable, scalable systems. In our next video, we'll explore distributed transactions and two-phase commit. Don't miss it.
Want to build systems that scale and never fail? Hit subscribe, turn on notifications, and join me for the next episode. Because great systems don't just work, they achieve consensus.